Hello world, Liu here, and here's part 9 of the Python from 0 to 1 series. Today, we'll be talking about logical operators, which include the AND, OR, and NOT keywords in Python. So before we start, let's do a brief recap of if-else statements. So let's say I have a score is equals to 70, and if my score is 50 or above, I pass, and if my score is 49 or below, I will fail. So first things first, we use the if keyword, and score is more than equals to 50. So I'm going to print pass, and else I'm going to print fail. So here, if I run this, I'm going to get pass. However, if I change my score to, let's say, a 30, and if I run this again, I'm going to get fail. So once again, to recap, I use the if keyword, and after the if keyword and before the colon, I put my condition here. So this condition will evaluate to either a true or a false. So if I print out my condition here, score is more than equals to 50, I'm going to get a false. But once again, if I change this to 70, I'm going to get a true. But what if I told you that we can have more than one condition in the conditional statement over here? We can actually do this using our logical operators. And first, let's start with the AND keyword. So next, let's say we have a student that wants to get a scholarship. But to get a scholarship, he needs a score of more than 75 and a conduct of excellent. So let's create a conduct. So let's say conduct is equals to excellent. So let's change this first. You get a scholarship. And here we have no scholarship. So here, the student needs to fulfill two conditions in order to get a scholarship. So after score is more than equals to 75, we add a AND keyword. And after the AND keyword, we can add in our second condition. Conduct is equals to excellent. So for the AND keyword, score needs to be 75 and above, and also conduct needs to be excellent for this entire thing to be true, and for this statement to print. So let's just copy this and print it here so that we have a better idea of what's happening. So if I run this now, I'm going to get no scholarship, and this condition is going to evaluate to false. And this is because my score is currently 70. So because this evaluates to false, this entire thing will evaluate to false. However, if I change this to, let's say, 78, now my score is actually more than 75, and this statement will become true. So this statement is also true, and therefore this entire statement will evaluate to true. So if I run this again, we will get you get a scholarship, and this statement will evaluate to true. So similarly, if the student's conduct is just okay, and if I run this, I'm going to get no scholarship. So because this statement is false here, the entire statement here will also be false. So next, let's move on to the OR keyword. So here, if we replace this with an OR, only one of the conditions need to be true for the entire statement to be true. So here, if I run this, I'm going to get you get a scholarship. So if I run this, I'm going to get you get a scholarship, and this statement will evaluate to true. And this is because score is 78 and is more than 75, which means that this statement evaluates to true. This statement evaluates to false currently, but it doesn't matter because we are using OR, and therefore this entire statement will become true. So similarly, let's say conduct is excellent, but score is 71. So if I run this again, the student will still get a scholarship, and this is because conduct is equal to excellent, and this statement itself is true, which causes the entire line to be true. Next, let's move on to the NOT keyword. So here, the NOT keyword will simply flip true and false. So here, let's say if I print not true, I'm just simply going to get false. And similarly, if I print not false, I'm simply going to get true. So what if I print not true and not false? So if I run this, I'm just going to get true and false, because not true is false, but not true will be true again. So let's use the score example for this too. So score is equals to, let's say, 56, and if score is more than equals to 50, print you pass, and else print you fail. And if I run this, I'm going to get you pass because score is 56 and it's more than 50. So let's use the not keyword here. So if not score more than equals to 50, and let's flip this, you fail, and this one is you pass. So if I run this, we are still going to get you pass. So here, remember that the not keyword will simply flip a Boolean value from true to false or from false to true. So next, let's talk about De Morgan's law. So De Morgan's law states that not bracket x or y, when we expand the bracket, we will get not x and not y. So here, when we expand the bracket, the or becomes a n. And similarly, in not bracket x and y, if we expand the brackets, it will become not x or not y. So similarly here, the and keyword becomes a or keyword when we expand the brackets. So while this might seem confusing at first, let's try to understand this with an example. So let's say to get a scholarship, a student needs to have above average score and his conduct is excellent. So let's say score above average is equals to true and conduct is excellent is equals to true also. So if score above average and conduct is excellent, print you get scholarship, else print no scholarship. So if I run this, I'm going to get you get scholarship. And this is because both score above average is true and conduct is excellent is also true. Here, if I change one of them to false, I'm going to get no scholarship. So let's change this back to true. So I'm going to copy this and comment this out. And let's write this in a slightly different way. So here, if not bracket score above average and conduct is excellent, so this one is no scholarship, and this one is you get scholarship. And so if we print this, we get the same result. And once again, let's copy this and comment this out. So now let's expand the brackets. So if not score above average, and the n needs to change to a or, and not conduct is excellent. So here we are saying that if either 1, the student's score is below average, or 2, the student's conduct is not excellent, there will be no scholarship here. So here, notice that De Morgan's law is kicking in and is correct. So next, let's remove this and work with another example. So let's say that Tom is allergic to apple and orange. And let's say that there is a dessert that contains a bunch of fruits. So let's create a variable contains apple is true and contains orange is true. So logically, if contains apple or contains orange, let's print Tom cannot eat this because he's allergic to both apple and orange. Else, Tom can eat this. So if I print this, I'm gonna get Tom cannot eat this because both are true. However, if I make it such that only one is true, Tom still cannot eat this because it contains oranges. So next, let's copy this here and let's comment this out. And let's add a not in front. If not bracket contains apple or contains orange, Tom can eat this. And else Tom cannot eat this. So let's run this again. And we have Tom cannot eat this. And similarly, now let's expand the bracket. So here, the or must change to an n. And let's add a not here. So if we run this, we'll still get the same result. So what we are saying is that only when a dessert does not contain apple, and it also does not contain oranges, only then Tom can eat this. So here, notice that this part of De Morgan's law works also. So anyway, thanks for watching, and hopefully this was clear and easy to understand. See you in the next one.